Yeah. Okay, good. I'm not available for lunch support today. Sorry. Tonight's homework is integration techniques. I already sent you guys. That was the video. I think I sent it on Sunday. And then last night you guys would have received another video from me. That's the one that says Thursday night's homework. I'm trying to stay far enough ahead in the video creation process so that those of you that you know, like there are good nights for you to do homework and there are not so good nights for you to do homework. Maybe you've got a church thing, you've got a sports thing. Some of you have meetings with your parole officers. I understand. Some of you wait up all night long for that like just right deal to come on, so you spend your $300 so that tomorrow you can turn around and sell it for what, $900? $1,000, okay? I get it. So you've already got the video that you're watching tonight in integration techniques, and you get the video that you're going to watch Thursday night for Friday's class. And I'm just going to keep plowing on through. The progress monitor is happening on Thursday. We've got 2 more Thursdays to go, so keep that in mind. And lastly, there is a bonus opportunity for those of you that are always hungry for the more, right? This orange card counts as a test grade. I'm looking at participation, I'm looking at homework, I'm looking at did you bring your calculator to class all the times. If you take out the special topics packet, specifically I want you to take a look on page 37. Okay? Page 37 is the opening activity we're going to look at right now. You already have notes on 38. We're going to work through problem number 39 in a little bit. The bonus opportunity is on pages 40, 41, and 42. There's a grand total of 8 multiple choice questions. Do those tonight or do those tomorrow night. Just show them to me that you've done all of them. This is excellent preparation for the progress monitor test on Thursday. And it counts as you're going above and beyond. Okay, I'm going to watch the clock. At 11:15, we're going to start the quiz no matter what. All right, so, I need yeah. It's on rate functions. I told you guys about it yesterday because rate functions are so important to me that you're going to get a lot of practice with rate functions. Okay, so let's just kind of talk through this opening problem here on page 37. Okay, you're going to complete as many of these statements as you can with your partner. Focus topic for today is rate functions. And if you went to AP Summit number 1, you get to go to the session with, led by Ms. Cooper from Southeast. She did rate functions at AP Summit number 1. AP Summit number 2 at Braze Oaks, that was with Mr. Ayers, for those of you that were there. And then AP Summit number 3, that was this past weekend. This was with Ms. Ziptak. Okay, apparently nobody was there. Anyway, it was with Ms. Ziptak. But these rate functions, these are all these in and out problems, right? The College Board loves them. Those, you have rate functions like the rate people are entering an amusement park and the rate people are leaving an amusement park. And maybe there are people already in the amusement park. You guys know what I'm talking about? Mm-hmm. Right. We spent a whole lot of time here because rate functions is one of the most heavily assessed topics on the AP exam. So this particular question, I just want to get you guys started on this and then I'll stop talking and give you guys time to work on this. Let the function a of t represent the amount of stuff at any time t greater than or equal to 0. A of t represents the amount of stuff, not a rate, but an amount. Maybe you also want to use the word total here. Now I'm not going to tell you what a of t is, but it's a function. And then I might give you an equation, but in this case not. Let r of t represent the rate at which we are gaining stuff. So whatever the stuff is, r is the rate that I'm gaining for this time interval 0 to 14. And let s of t represent the rate at which we are using the stuff. So I think about the gaining as like that's the in, and the using, that's the out. Water coming into a swimming pool, water coming out of a swimming pool. I'm very focused on swimming pools. We get a swimming pool on Friday. Can't wait. The graphs of r of t and s of t are shown at the right. So there we go. I'm not going to give you equations. I'm not going to give you something to type into your calculator. I'm just going to give you the graph and some information, and we'll go from there. All right, so have a quick conversation with somebody near you. If a of 0 is equal to 500, write an integral expression which can be used to determine the value of a of t at time t equals 5. What's the calculus you would do to find the amount of stuff at time t equals 5? What would you do? The amount of stuff at time t equals 5, where does that come from? Seeing some stuff that I like and some stuff that I don't like. A of t, I just want to make this super clear one more time. A is how much you have. It's not a rate, it's the total amount that you have. So like the total amount of people in the park, the total amount of water in the pool. So the amount that I have at time t equals 5. Well, how much do I have at time 5? I've got to consider how much I had in the very beginning, right? The 500, we had a fancy word for that?
Initial.
That a of 0 is equal to 500? Some people call it the starting value. We like to call it the initial condition. It's your initial value. Okay, so it's what you started with. Now, the big mistake that I'm seeing is a lot of folks are saying, we're going to do an integral from 0 to 5. That's not the mistake. That's good. It's the function that you're integrating that's the problem. It's not a of t, although that is the popular wrong thing to do. A of t is how much you have. R of t is how much you gain. It's like the stuff that's coming into you. And S of t is the amount that you're using, the amount that you're losing in this process. You integrate rate functions. So what I need is the integral from 0 to 5 of r of t dt. It's the amount you've got in the beginning, plus r of t is the rate that you're gaining stuff. The integral is how much. Remember we used to have the how fast, how much conversation? R of t is how fast. The integral is how much. Now some other folks said then minus the integral from 0 to 5 of s of t dt. How are we feeling about that? Nobody has any objections to this? Just me? Kaylin, what's the problem here?
The rate at which it's using, it starts at 5.
We don't actually start using the stuff until time t equals 5 happens. So the 500 in the beginning, that's good. How much you gain, yes, but you're not actually using stuff during this first 5 hours. So this guy here, just leave it alone. We're okay? All right, here are the ones I want you to focus on while I do a lap and check in the homework. Number 2, number 3, and then number 5. Skip 4 for a little bit. 2, 3, and 5. I'm going to come around. I need to see notes from last night. Orange card, please. Have them out ready for me. The notes should be on 38, and then 44. Checking your absent history. Right. Okay. Yes, you did. 38. Up on the shelf. 44. Thanks, Delia. I just had it.
Oh, in the window. He said up in the shop. I was like, where?
All right, I'm assuming at this point everybody's finished up number 2. How much do you have at time t equals 14? If all goes well, the amount at time 14 is going to be 500 plus the integral from 0 to 14. R of t dt, hope everybody's good with that. Now you are using stuff, so it's going to be minus the integral from 5 to 14 of s of t dt. How many guys had that as your setup? Okay, that looks like most people. We're in a good place. Okay, number 3, a of 0 is still equal to 500. Write an integral expression which can be used to determine the value of a of t for any value of t. That's not the same as at time t equals 14, but for any value of t. Jose, if you can turn that off. So how do I find the value for a of t? It's going to be that 500, your initial condition. Plus what? We definitely need an integral. From where to where? From 0 to t. You're going to start at time 0. Now what are we integrating?
R of t dt.
Now I heard a couple of things right there. I heard r of t dt, and I heard r of x dx. The one that I like better is the r of x dx. If you remember way back in the day when we were doing this a lot, the College Board, they're really picky. If you're using a variable for your limit of integration, do not use the same variable in your integrand. If, however, how many guys had the r of t dt? Naum had that, Roberto had that, Kaylin had that. You're not going to lose a point for that. They're very, very forgiving, but it's going to sometimes get confusing, so it would be good. That guy has to be t, and then this is going to be the r of x dx. Minus, now you've got the integral from 5 to t, s of x dx, or s of a dA, and I hope everybody's good. All right, last one that we're going to do together. Identify all intervals for which a of t is increasing. What has to happen for the amount of stuff to increase?
We're getting more than what we're using.
You're going to do what?
We're getting more than what we're using.
We're going to do what? 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 We're going to do if you're gaining more than what you're losing or you're using, the amount that you have should go up, right? But I want to make sure we're using the language of rate. It's not the amount that you're gaining is greater than the amount that you're losing. It's the rate that stuff's coming in is greater than the rate that stuff's going out. It's coming into you faster than you're losing it. If I look at the graph, when does that happen?
T is greater than A.
You have to gain faster than you're losing. So I'm hearing a lot from what, A to 14? Well, let's see. From A to 14, here's R. R is greater than S. R is the rate that you're gaining. Is everybody okay that you're gaining faster than you're losing?
Yes.
Everybody's okay? R of T is greater than S of T. I agree on the time interval 5 to 14. Love the time interval 5 to 4. Not 5. My bad. A. Cannot give you the full credit though.
Explanation?
There is some other time interval where the amount that you have increases before 5. Why before 5?
Because you don't start using it until 5.
Right? On this interval, 0 less than t less than 5, the only thing that's happening is I'm gaining, right? Stuff is coming into me. Water's coming into the pool, but no water's going out. There's not a leaving function. The hose is running, water's coming in, water level goes up. All friends are okay? So on this interval, A to 14, it's true because R of t is greater than S of t, but on this interval, you could say something like no S of t, or maybe you want to see R of t only. Something to that effect is great. All right, so with that said, I want to stop talking, because what I promise you guys is by watching the videos at night at home, what you're getting is more work time in class. I'm going to put 19 minutes on the clock. If you flip over to page 39, 39 is a rate functions question. You have your calculator, you're going to need your calculator. You've got the functions that you're going to play with, use them. This is going to set you up to do really well on the quiz that starts at 11:15. I'm just going to circulate around the room, help out as necessary. Maybe sprinkle some water on a pizza plant so that I can get a pepperoni pizza by the end of the period. And we'll go from there.
I like that playlist. You play Oceans, you play.
Oh, yeah, sorry. I was afraid let the bodies hit the floor. There's occasional, there's like the Christian music playlist, there's like the musicals, there's the instrumental, and then there's the House Is All Mine, and it just gets hard and heavy real quick.
Oh, yeah, this is amazing. Yep, I do it at home. I find it hard to watch an entire music. You share that playlist to everybody.
Yeah, I got lots of Facebook posts and emails about that, and smart ass over here. Your grade went down by 5 points after that for some reason.
Oh, my God.
Hey Juan, how you doing back there? Just checking. Endless whole thing. Right, like the mistake somebody's making, like, oh, I need to find the derivative of 45 times cosine. That's going to be negative 45 sine.
I read the calculation, the function.
So you're going to type the function into the calculator. You probably already did that.
That's math.
And then it would be best to go over to your calculate screen. Go to the calculate screen, yeah. Well, so you could do it, oh, and you're going to the templates button where it has like all the stuff in it, or you could just hit menu. There's a clue.
Do you get it?
Yeah, since we're in that class, yes. And now you want a derivative. Yeah. Leave the variable as x and
I told you, man. I knew you left.
the derivative is always going to be how fast does g change.
What is this?
Okay, how are we doing, friends? That number is perfect. 1 point, you get the number value. Oh, did I not get you guys? Oh, my bad. My bad.
You gotta get set up.
Okay, can we get the video? Notes for 38 and 44. Okay, you find this will be a good experience. Okay, Abraham, we're talking smack about my playlist. Clearly you watched the video. Roberto did not make fun of me, so that's a check. Sarcastic posts on my YouTube channel.
Did you see it? Are you calling? Yeah.
Part A asks for g prime of 5. Yes, you know how to find this derivative. Use your calculator.
Negative 24.
At t.
It's just a derivative.
Do you know how to endpoint? You don't know how to endpoint, huh?
Tell me about g. G prime means how is this function changing? How is the function increasing or decreasing? That's g prime.
Negative 24.
It should be negative. Negative 24.587 or negative 24, something like that. Well, read what you're asked to do in part. Right. They're always going to ask you to interpret. Yeah. The rate at which unprocessed gravel arrives is decreasing. You're off to a good start. Okay, I'm assuming that at this point everybody has found g prime of 5 and with negative 24 point, what is it? 875?
5.875.
Okay, negative 24.587. Honestly, how many of you guys have this as your derivative answer? This needs to be the easy thing. Your calculator is doing the hard work for you. The tough part is always the explanation. The sentence needs to look like this. At t equals 5 hours. Tell me what's happening at this moment in time. Well, tell me about the function. What does g measure? Go back to the original problem. What does g measure? Not the gravel arriving. That's not specific enough. What is g measuring? Right? It's the rate that the unprocessed gravel arrives. At t equals 5 hours, the rate that unprocessed gravel arrives. I'm just using their words back on them. Unprocessed gravel arrives. What's that rate doing?
It's decreasing.
How do you know decreasing? Decreasing because of the negative. It decreases at a rate of, now give me the number, 24.587, and if you're going to lose the point, here it comes. It's the units. G is already a rate function. G prime is a rate of a rate. What do the units have to be? Okay. The way I like to think, G prime is a derivative. The other way you can write it is dg dt. What are the units for G? Tons per hour. What are the units for T? Hours. So what are the units for the derivative? It's tons per hour, or tons per hour squared. That's great. You have to nail the units. The units are going to get you here. All right. So 1 point if you came up with the numerical answer, 1 point for the explanation. You need all the things. You start with the time interval, or the moment in time. You tell me about that function. You tell me if you're increasing or decreasing. You give me the number, and you get the units. Okay. Keep going. Keep going. Yep. If you get any part of that wrong, if you forget to mention at time t equals 5 hours,
Yeah, you're right.
if you say decreasing at a negative rate, you lose the point. Any piece that's missing, the point gets lost. Everybody's on part B or further than that. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation.
From 0 to 8. Yes, sir. I mean, that's what I'm
Three, 4, 5,
Wait, what you had 500 for?
6.
I think
Okay. Only made it halfway around the room. 6 of you have the wrong setup because you're not reading this carefully enough. You're one of them. That's 7.
So we don't need to buy one. We don't? So I'm supposed to grab that
Let's keep going. Eric is not on the list of 7. Yeah, unfortunately, I'm on the list.
I do want to say that.
Okay. In part B, the issue is I'm asking for the total amount of gravel that arrives. That's it. Don't include the 500. It's not about the 500. It's only about the amount that arrives. So how much has come in? Well, that's going to be your integral from 0 to, what are we integrating to? 0 to 8. And Kaylin, not to like totally call you out here, but you wrote the 90 plus 45 cosine t squared over 18, which is fine. That's fine. But you could also just get away with writing the integral from 0 to 8 of g of t dt and be done. And you get the 1 point. And what are we getting for the number?
825.
825 point. Point what?
551.
551. And I need the units.
Tons.
Is everybody clear that this is going to be tons? Has to be tons. Okay. Don't include the 500, even though it's the initial condition, because my question is how much got processed, not how, or how much arrived, not how much was in there in the beginning. So 1 point for the integral, 1 point for the numerical value. If we could turn the camera, I'm going to go over here. I want to talk us through this guy here. 1/6 the integral from 2 to 8 g of t dt. Have a conversation. What are you being asked for here? Don't talk to me yet. Talk to the folks around you. Yes, ma'am. You're in the right place.
Bro, it's easy, bro. All you gotta do is 8. Because you gotta find
All right, friends, we'll plug it together. That 1/6 is the clue. You're integrating from 2 to 8. This is a 6-hour interval. Why would you ever multiply by the 1/6 or divide by 6?
Every hour.
You're looking at every hour. What you're looking for is average. Okay? So the sentence, right? This is that explanation sentence again. Okay? I always start with the time interval. So when is this going to be true? From t equals 2 to t equals 8 hours. You guys just told me that this represents average. So from t equals 2 to t equals 8 hours, what's happening? The average. What's G?
Rate.
Be specific.
Which process gravel arrives?
This is the average rate that gravel arrives. Okay, from t equals 2 to t equals 8 hours, this is the average rate that gravel arrives. What are we measuring in? What are you measuring? You're measuring a rate. Right? What's the unit's going to have to be for a rate? It has to be tons per hour. When it comes to these average problems, whatever the units are here for the function, that's going to be the units for your average as well. We used to talk about, like my brother Jeff and the M&Ms. Jeff ate 200 M&Ms every hour for 3 hours. On average, he ate 200 M&Ms an hour for every 3 hours. Everybody good? Mm-hmm. All right, now last class, some of them went straight to their calculator and said, okay, good, let me integrate. 1/6 the integral from 2 to 8 g of t dt. Here's the problem though. What am I asking for in part C? I'm asking for the trapezoid. I want a trapezoid approximation. Okay, and then it's been a while since we've done this. The trapezoid approximation. Well, a couple of things we need to make sure we're clear on here. How many trapezoids?
3.
We want 3. Now, are these like 3 random trapezoids? Are these 3 trapezoids of equal width? 3 of equal width. Okay. How wide is each trapezoid?
2.
Where'd that come from? Where'd 2 come from?
8 minus 2 is 6.
8 minus 2, it's a 6-hour interval.
Divided by 3.
And divide by 3. And so you might do like a little delta x's, 8 minus 2 divided by 3, you get 2. Like way back in the day when we started, we'd like draw the little interval and we'd do the partition. So you go from 2 to 4, 4 to 6, and 6 to 8. Now I'm not saying that this is what the graph looks like, but let's say these are your points. When you make your trapezoids, right, those are your bases. So there's a base, there's a base. You connect them just to get some points there. How do I find the area of a trapezoid? 1/2 base 1 plus base 2 times the height. How long are the bases? How long are the bases?
F2.
Not f of 2, there's no f here.
G of 2.
G of 2, so it's a 1/2 of g of 2 plus your next base, g of 4. So 1/2 base 1 plus base 2 times 2 because that's the height. Okay, so that takes care of this first one. The next one? There you go, plus 1/2 g of 4, g of 6 times 2. Got it?
Plus 1/2 G of 6.
Plus 1/2 g of 6, g of 8 times 2. Now be careful. Although I love this and we're doing a good job here, there's a problem. The 1/2 g of 2 plus g of 4 times 2, the 1/2 g of 4 plus g of 6 times 2, the 1/2 g of 6 plus g of 8 times 2 is great. But we forget something. We forget about that 1/6 that we needed in the beginning. This guy here, all of this has got to get multiplied by 1/6, and I want to make sure that we get enough time to talk about part D. Is everybody okay with plugging this in on the calculator? Like, we're good with this? Okay, what are the things you could do to simplify the plugging in on the calculator? What could you do to make the plugging in part easier? Remember, there are some patterns here. Delia, what do you see?
Last time we said that we can use 0 multiplying with 1/2 times and you're multiplying the two, you can. I don't
The
know
word is
what you
factor?
call it. Yeah, there you go.
Right, everybody's getting multiplied by a half and everyone's getting multiplied by 2, so you could factor those out in front. What else?
Why can't you just multiply, like, it's gonna be 2 times 1/2, it's gonna be 1. So
Right,
then
you
so
could
just
also
add.
do that in this case, 1/2 times 2 is 1, so like why bother?
Just add.
That would be okay. Or, like, what would happen all the time, you can always factor out the half and the 2. There's something else that can happen though that could make life better. What else?
You can combine them, so since you're adding, so G of 2 is just 1, with 2, G of 4, 2.
G of 2 shows up once, G of 4 shows up twice, G of 6 shows up twice, G of 8 shows up one time. We're good? All right, last one, part D. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? What's happening with the amount of unprocessed gravel at the plant? We'll talk in a minute. You might want to go back and read the problem one more time. One. Is the amount of unprocessed gravel at the plant increasing or decreasing, and why? Decreasing?
Like part A.
Now here's where you want to be careful. I heard from Jose and from other folks, well, G prime of 5, we had some negative number, and so you're saying that G is decreasing? True, G is decreasing at time t equals 5, but G is the rate that unprocessed gravel is arriving. This question in part D is about how much do you actually have at the plant? Is that amount increasing or decreasing? There's actually 2 things happening at this plant. I don't think anyone's picking up on the second thing.
Processes at 100 tons per hour.
You've got unprocessed gravel that arrives. That's what G is. So in part D, you've got G of 5, and this tells me how fast the unprocessed gravel arrives. But what's the other thing happening at the plant? You've got it being processed as well. So what's the rate that I'm getting processed at time t equals 5? 100. What's the rate that the processed gravel is arriving? Be careful, I don't want a derivative here. I just want to know what's G of 5 at this point.
98.14.
98.14. 98.1408. The processed gravel arrives at a rate of 98.140 tons per hour. I'm processing it, I'm working on it at a rate of 100 tons per hour. What happens? Uh-oh.
No, decrease.
I just heard both things. It arrives at this rate, I process it at this rate, so I'm processing faster. So I'd say amount of gravel, what's it doing? Decreases at t equals 5, and that's because G of 5 is greater than P of 5. Okay. All right, if you guys could leave out the orange card, but put away everything else. We're going to start on the quiz. You're going to have enough time on the quiz. I promise. 3, 5, 7, 1, here we go. 12. Yes, it's absolutely calculator active. All right, you guys have the rest of the period. Jackie, if you could turn the camera off.